Hi friends. Welcome back. Today we are for you with a new video topic which includes model previous question paper for physics main students of 5th semester on the subject classical mechanics and theory of relativity. Hope all enjoys. Keep on track with us for more video notes, question papers and all. Comment us if you needs uploads of your kind. Section A. This section contain 4 bunches each of 4 questions. Answer all questions. Each bunch carries a weight of 1. I. Choose the best option. 1. According to Kepler, planetary orbits are a. Circles, b. Parabolas, hyperbolas, d. Ellipses. 2. Coordinates that do not appear in the Lagrangian explicitly are called a. Cartesian coordinates, b. Cyclic coordinates, c. Generalized coordinate, d. Inertial coordinate. 3. Number of generalized coordinates required to represent a particle constrained to move on the surface of a sphere is a. 1, b. 2, c. 3, d. 4. 4. Rotational invariance leads to conservation of a. Angular momentum, b. Linear momentum, c. Total energy, d. Kinetic energy. 5. Twin paradox is related to the relativistic effect of a. Length contraction, c. Time dilation, b. Causality, d. Variation of mass. 6. Effect of centrifugal force will be maximum at the a. Center of the Earth, b. North Pole, c. South Pole, d. Equator. 7. For a rigid body under translational and rotational motion, number of generalized coordinates is a. 2, b. 4, c. 6, d. 8. 8. For a system of 2 particles with identical mass m, the reduced mass is a. 4m, b. 2m, c. m, d. m by 2. Fill in the blanks. 9. Homogeneity of flow of time leads to the conservation of dash. 10. Rotational invariance leads to the conservation of dash. State whether true or false. 13. In a center of mass system total momentum is 0. 14. Hamilton's equations are first-order differential equations. 15. Coriolis force is always directed away from the center of the Earth. 16. Michelson-Morley experiment proved the existence of ether. Section B. Answer any 8 questions. Each question carries a weight of 2. 17. What are inertial and non-inertial coordinates? Give examples for both. 18. Explain the concepts of isotropy and homogeneity. 19. Show that angular momentum is conserved in a central force field. 20. Discuss how momentum and energy transform between laboratory and center of momentum coordinate system. 21. Differentiate between elastic and inelastic collisions. 22. What are generalized coordinates and generalized momenta? Give examples. 23. Write down Lagrangian and Lagrange's equations for Atwood's machine. 24. Show that momentum corresponding to cyclic coordinates are conserved. Illustrate this in the case of free particles. 25. State Galilean transformations and show that Newton's first law is invariant under these. 26. Write a brief note on mass-energy equivalence. 27. Air space-like and time-like intervals. 28. Derive the expression for relativistic time dilation. Section C. Answer any 5 questions. Each question carries a weight of 4. 29. Lagrangian for a one-dimensional system is given by Li equal to half mv square minus half kq square, where m and k are constants. Write down the Lagrange's equations and solve them. 30. Write the Hamiltonian for the projectile motion problem. Restrict to xy plane and assume that acceleration due to gravity is a constant and get the Hamilton's equations of motion. 31. Periods of the Earth and Jupiter are in the ratio 1:12. Make an estimate of the ratio of their distance from the Sun. Hint. Assume circular orbits. 32. A particle of rest mass 10 raised to minus 30 kg is accelerated to a speed 80% of speed of light. Estimate its relativistic mass. 33. A particle of mass m in its rest frame decays into 2 photons. Derive an expression for energy and momentum of each photon. 34. In an Atwood S machine set up mass 1 kg and 1.02 kg are attached to the end of a string over a pulley. Find the acceleration. G equals 9.8 meter per second. 36. How much energy will be produced in a star of mass 10 raised to 30 kg if 0.7% of its mass gets converted into energy by nuclear fusion of hydrogen into helium? Section D. Answer are any 2 questions. Each question carries a weight of 15. 37. Sat and explain Kepler's laws and deduce them from Newton's law of gravity. 38. State D. Alembert's principle and derive Lagrange's equations. 39. State postulates of relativity and derive Lorentz transformations. Thank you all. Please like, share, comment and subscribe us for more videos. Comment us your suggestions, so that we are here to help you. Once again, thank you. Keep watching. Keep supporting.